Hey, mathematicians, is Mrs. Shopper coming back with more about proving lines parallel? It's going to build on what we talked about in 3.2, where we're looking at those angle relationships, corresponding angles, alternate exterior angles, consecutive interior angles, and so on. So first thing I want to do is bring us back to what a converse is. And we talked about that in chapter 2. The converse of a statement is where you take your if and your then and you switch them. Okay, so if it's snowing outside, then it's 32 degrees. The converse would be if it's 32 degrees, then it's snowing outside. So switching those if then, because we're going to build on that today. So the converse of a statement is when you switch your if and your then. So when we look at the converse of this corresponding angles postulate, okay, converse is a very key word here. Right here, converse, okay? Because what we're doing is we're taking the corresponding angles postulate that says if two lines are parallel, then their corresponding angles are congruent, and we're taking the converse of that. So it says if two angles are congruent, then the lines are parallel. So we're taking, today's lesson is really taking the converse of everything we talked about in 3.2. And this is why it's important to know those and to remember those and to practice those, is because we continue to build and build and build. And so practicing as you go along is going to be much more efficient and helpful than trying to cram it all in, okay? So I came in today's lesson believing that we all know what the corresponding angles postulate is. So to find the converse of that, we take and flip that if-then statement. So with the converse, we're saying if the corresponding angles are congruent, then the lines are parallel. So if 1 and 3 are congruent, we can say line A and line B are parallel. The theorems and postulates prove angle relationships. The converses prove lines parallel. I'm going to say that one more time. You're going to want to write that down. The theorems and postulates in 3.2, okay, the theorems and postulates prove angle relationships. The converses prove lines parallel or perpendicular, okay? They hit two different parts. The parallel postulate, this is new. If a line and a point, if given a line and a point not on the line, there exacts one line through the point that is parallel to the given line. Basically what that's saying is, if I have a line, okay, and I have a point, there is only one line that goes through this point that is also parallel to this line. That's what this postulate says. If I have a line and a point, there is only one line I draw through that point that is also parallel to this line. That's what all those words mean. Point and a line, there's only one line that goes through there. Here's some more converses. Again, paying attention to the vocabulary. We try to do a really good job. We're not always successful, but we try to have the names really match what we're saying. So alternate exterior angles, converse, okay? Consecutive interior angles, converse. Alternate interior angles, converse. Perpendicular transversal, converse, okay? Take some time and write this down. Pause the video if you need to. Write down what you need to do. But what we're saying in each of these cases is if we know something about that angle pair, then we can prove the lines to be parallel or perpendicular. Take time to copy down what you need to. So let's apply this. We know that angle 1 is 103. Oops. We know that angle 4 is 100 degrees. That's what it's giving us. Is it possible to prove that any of the lines are parallel? If so, state the postulate or theorem that justifies our answer. Okay. Well, 1 and 4 are alternate interior angles. These two are not congruent. So therefore, A and C aren't parallel. If I know this is 103, I know that this is 103. If 4 is 100, the corresponding or the consecutive interior angle says that this needs to be 80. And that doesn't equal 180. So there's nothing in here that can be parallel. None of them can be proven parallel. We just don't have enough information or accurate information to make that happen. All right, let's take a peek at this one. Find the measurement of angle ZYN. So ZYN is right here. Find this measurement so that PQ and MN are parallel. So we want to make sure that we can get both of these lines to be parallel. PXW, this angle, and ZYN are alternate exterior angles. Alternate exterior angles, if they're congruent, then their lines are parallel. And so I'm going to use the exterior angles converse to prove line PQ and line MN parallel. So I'm going to set up 7x plus 35 has to equal 11x minus 25. In order for these two to be parallel, the alternate exterior angles must be congruent. And so I'll have that 4x is the same as 60, so x equals 15. I'm going to go back to my original question. It says find the value of or the measurement of ZYN. So I need to put 15 in for x. So 15 times 7 is 105 plus 35. So in order for these two lines to be parallel, the value of ZYN is 140 degrees. 140 degrees. And what I use, because I want to justify my answer, is the alternate exterior angle converse. It's very important that you include converse with that and justify it. Okay, so here's one more example and then we'll give you some time to work. In the windows shown below, the diamond grid pattern is constructed by hand. Is it possible to ensure that those wood pieces that are in the same direction are parallel? If so, explain. If not, why not? So how would someone who freehanded this know if these are all parallel? What you're going to want to do is find a transversal that goes through all of them. So this transversal goes through all of these parallel lines. That's going to help us be efficient. Okay, not the last one, we'll have to do that. But all of these angles, if this extended, this angle, this angle, this angle, these are all corresponding. I would have to measure each of those angles to make sure that they're all the same measurement. And then that way I could ensure that all of my lines were parallel. Are there other ways to do it? Sure. That's just kind of my idea. You might have had something different, and that's okay. So you're going to work on proving lines parallel. It's really important when they say explain your reasoning or justify your work that you name the theorem, postulate that makes that true, that allows you to do that step. So it's really important, kiddos, that you're studying what these mean, that you're practicing them. You really need to know those off the top of your head. Okay, take the time to study, take the time to practice. Jump on at any Google Meets that you want. We're going to try to make this work the best we can for all of you. We want you to do well, and I need you to do your part too, okay? So good luck. If you have any questions, let me know. Otherwise, I'll touch base with you next time. All right, take care.